Welcome to qnawire.
Here we have a piston pushing on a circle, a disc, and it's freely slotted in a gear. And it'll move a rack on top, A, while there's a fixed rack on the bottom, B, that's not moving, such that it rolls on the top with a velocity of 0.4 feet per second. We want to determine the velocity VP of the rod at this position. So we draw the diagram here. It's a little complicated because there are a lot of pieces here. But what we can do is look at some triangles and use a law of sines. So we know that the sine of 90 degrees divided by the length between O and D, which is a side length we know it's 6 inches or half a foot, has to be the same as the sine of 45 degrees divided by the length C0, which is the distance between the center of the circle O and the point where the piston makes contact up to the right. So that's C0. So we can solve this for C0 such that the length C0 is 0.353 feet. So that's the first part of this. Then we're going to want to find omega in terms of our velocity. So we can look at this as the angular velocity of the entire gear itself is omega, and that will equal the velocity that the gear is moving with divided by the radius of the entire gear here, that entire disc circle. The velocity the gear is moving is simply going to be half the velocity that A is moving at because B is fixed. So half the distance up at V0 must be half of that. So that's 1/2 VA divided by R. And we find then that omega must be 0.4 radians per second when we put in VA and R, which is half a foot. And here we want to be careful and make sure we put in the magnitude of VA and not the negative 0.4 that just is saying it's moving to the left. Okay, so next we would like to find the velocity of C with respect to the origin. And that will simply be the length of C0, which we found above, times the rate of rotation, that angular velocity, omega. Well, we know omega was 0.4 and C0 is 0.353. So when we put those numbers in, we find that this velocity of C with respect to O is 0.141 feet per second. So that was somewhat simple for us. We can then draw a velocity diagram to help us diagnose the situation a little bit. We have the velocity of point C, which will be moving up and to the left, because C is free to move along this line here. So we have VC. We have VO, which is the velocity of the center of the sphere here. So if we go up and to the left, then we have the velocity of c with respect to the origin. We also have the velocity of p, and if we go down here, then we have the velocity of p with respect to c. And we can use these triangles to help us find the velocity of p, which pretty simply in this diagram, Vp and Vo actually have to be equal to each other, which will make our life a little bit easier if those two are moving together. So Vp equals Vo, which we already found was just half of Va. Va was 0.4 feet per second. So if we divide that by 2, we get a velocity of 0.2 feet per second.